Problem 2 from the 2003 E&M AP test. I'm going to be honest with you, this might be the most straightforward problem of them all. It's actually very, very easy. It's kind of mystifying to me why they gave you this, but whatever. We know that we have a battery of 12 volts. It's hooked up to a resistor and a capacitor. When the switch is closed at t equals 0, the circuit is complete and you measure the current through to be something. The current starts off at a maximum value, it goes down. That should make sense because we are charging a capacitor. Using common symbols for the battery, the resistor, and the capacitor, draw the circuit that you constructed. It's very straightforward. We have a battery, we have a resistor, there is a switch, so this is my switch. Once it's closed, it's going to charge the capacitor. Now the one key thing here is that they need to include something to measure the current. They gave you the current as a function of time, so you needed to have a device to check the current. That is an ammeter, and you use an ammeter in series in order to measure current. Okay, we're going to come back to that here in a second when we talk about a voltmeter. The ammeter measures the current by being in series. Okay? Now, having obtained the curve shown above, determine the value of the resistor that you placed in the circuit. We know that the voltage is 12 volts, that's the battery. We know the maximum amount of current was 0.01. If you look at the graph, we can use V equals IR to get the resistor. The next part was probably the hardest part, which is what capacitance did you insert in the circuit to give the result above? We have to recall that the time constant is equal to R times C, and we always have in this e to the minus t over 4 term, this down here in the denominator, the e to the t divided by something, that something is the time constant. That's R times C, because this has to make something unitless up here, so it has to be a time divided by another time, and we did the unit analysis on this. That time constant is equal to R times C. So 4 is our time constant. We found the resistance from before, 1200. We multiply that by C, so we solve this to get the capacitor, which is 3.3 times 10 to the minus 3 farads. Okay? Now, in the last part, they give you a whole lot of language here. We have something that's going to be charging when it's in position A, something that's going to be discharging when it's in position B. So now what I've done is I have the battery here. It's going to come up, it's going to go into a resistor, into a capacitor. The switch is going to have 2 different positions. Don't even worry about this V over here. I'm going to come back to it here in a second. When we are in the A position, when this is down in the A position, the battery is going to run through the resistor and it's going to charge the capacitor, very similar to what I have over here. When we're in the B position, we take the battery out. Now the capacitor is going to run. It's going to act as our battery. It's going to run through the resistor. Okay, so this is sort of like charging your phone. We've talked about this before. So the A position, we're charging from the battery. B position, we're running off the capacitor. When you need to measure voltage, and here we have a voltage versus time graph, a potential difference versus time graph. When you need to measure voltage, you need to measure across with a voltmeter, okay? Because notice, the capacitor and the voltmeter are in parallel, and you know that in parallel means that the voltage must be the same. Over here for the ammeter, you want to measure current, and you know that the current for all 3 of these circuit elements is the same, provided that the ammeter is in series. The way an ammeter works is it's basically a very, very tiny resistor. So you're putting a very, very tiny resistor in here, so you're hardly changing the current. Ammeter needs to be in series, voltmeter needs to be in parallel. That's the main thing you got to pick up from this problem. Not a whole lot of calculations to worry about. That time constant was the only thing that I kind of forgot about, and I had to take a second to remember. But remember that that E term has to be raised to some negative time divided by the time constant.